So section 3.2, now we're given graphs or information and we're writing functions. So this is from the last section, factored form. We like it, it's easy to graph. And then I'm going to be saying roots, intercepts, zeros. These all mean the same thing. I'm talking about the x-intercepts on the graph. So we went over this last time. A quadratic has two factors, but now we're factoring in the leading coefficient. That's the a at the very beginning. And a can make the graph shrink, is what we say, or stretch. So it can make it bring closer to the axis or stretch apart. And these graphs here are kind of, we call them the parent functions. So this is x squared, this is x cubed, and this is x to the fourth. But once we change the numbers and we make them factors with leading coefficients, sometimes our quadratics, well, most of the time they move around and they're going to look like this. It could be really wide. And then once we have cubic, we start to get three different roots. It starts to look like this. And same with a quartic. That means it crosses 4 times, so it starts to look like this. So these are just the parent functions, but remember when we add numbers, when we add the leading coefficient, things change. So we're going to do an example. So write the equation of a cubic polynomial, so that means to the third power, degree 3, with roots -6, -2, and +3. And then we're given a y-intercept, and I'm going to show you why. So a cubic polynomial is this one. A x minus r1, x minus r2, x minus r3. We're given the roots, -6, -2, and 3. So now we're at, and I'm going to change this f of x to y, and you'll see why in a minute. We don't know the leading coefficient, but this becomes x minus -6, so it's plus. X minus -2, so it's plus. And then that minus goes with the 3. So just remember, and we've gone over this before, in your factors, it's the opposite sign of the root. All right, now we need the y-intercept. We need to solve for a. We need to figure out what's the leading coefficient. So we're going to use this point where x equals 0 and y equals -18 to solve for a. That's why we need that. And that's why I changed this to a y. Y and f of x are the same thing. They're interchangeable. But it's kind of easier to see that y is -18. We're solving for a, and x is 0. So we're going to put a 0 everywhere where we have an x. And now we solve for a. So the zeros make it easier. That's why we usually use the y-intercept. 0 plus 6 is 6, 2, and -3. Okay, remember parentheses mean multiply here. So we have 6 times 2, which is 12, times -3, which is -36. And I'm just going to write it a little. I'm going to write the -36 next to the a, right? This is a times -36. So I'm just writing it a different way so it looks like what we're used to. And now we want to get a by itself. So I'm going to divide both sides by -36. So a equals -18 divided by -36 is +1/2. So now I'm going to go back here, and our function is y equals, or f of x equals a, which is 1/2. We just solved for it. And then the rest stays the same. X plus 6, x plus 2, x minus 3. We're just going to do a rough sketch of the graph. It's not going to be totally exact, but we know enough that we can get an idea of what this graph looks like. So we know our roots are at -6, -2, and +3. Those are our intercepts. Remember, interchangeable. I'm going to say roots, I'm going to say intercepts, I'm going to say zeros. I don't say zeros as much, but they all mean the same. So we're crossing at -6, -2, and +3. And then we were given our intercept at 0, -18. That's going to be all the way down here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well, that's why it says sketch. Okay, so notice that between these points, we have to come down. So I know the graph comes down like that. And the only thing I don't know from our function is how high this goes. I got to come back down through that point. So if you wanted to figure that out, you would have to plug in points between here to get a better idea. I'm just going to sketch it and go back down right there. That's a general idea of what this graph looks like. If you want exact, graph it in Desmos or plug points into your function that you just found out.